So you guys took your data in what we'll call a radial format. So you took data outside your topo data. You located your instrument with relation to different traverse points or different known points on the site, and then you took your data in a radial format, meaning you had an angle relative to your back site and a horizontal distance, in addition to the elevation, the z direction, your vertical difference. The problem with doing that is that AutoCAD works in a 3-axis XYZ plane type of configuration, so it cannot take radial data. So if you remember when we went out and did the tank farm project, we had a spreadsheet that converted coordinate geometry to radial layout, so you could use the total station to lay out your centers of your tanks, your corners of your pump house, whichever it was. We have a spreadsheet here that's capable of doing the opposite. It can take your input in terms of point numbers, your description, your angle in degrees, minutes, seconds, your horizontal distance, your vertical distance, your prism heights, all of that, and convert it into coordinate geometry, northing, easting, elevation. Right? And the reason you need to do that is because in AutoCAD, which you'll see when we open that up, the points have to be imported in a PNEZD type of format. Right? They have to match the format of your data collector. So there's several different inputs. You can have PNEZ, right? Maybe you just have point number, northing, easting, Z direction with no description. You can have PENZD, in which easting comes before northing. But in order to have the data that we are going to give you from the data collector, you have to make sure when you import it into AutoCAD that it is in PNEZD format, right? And the reason for that, I'll show you the data. This data sheet came off of Mr. Van Duzen's data collector. He went out with Mr. McKeegan and did a topo of the site, which has 100 and, you can see the left-hand column is the point numbers. There's 180 points in this point file. You guys shot how many points when you went out there? 30 or so, right? So this is 180 points. There's a lot of data here. So to plot these manually would take a lot of time. That's why we're going to show you how to import point data into the AutoCAD. Now this comes off the data collector. You can see there's no headings or anything. Computers don't like extra information. The format of this is PNEZD. So the first number here, P, point number, 1005. N is your northing, 5006.8678, that's your northing. Your easting is 9884.0472. Your Z direction, 105.2702, right? So we have P, N, E, Z, and then D is description. This is pipe center line. Does that make sense so far? So PNEZD is the format of this data, and that's the format of how we're going to load it into the AutoCAD system. Right? The way you load it in has to match the format of the data itself. This is in a notepad file. So we're going to give you this data just so that everyone's is consistent. Every group had slightly different shots. You have a question? EZD. Point, northing, easting, Z, which is elevation, description. Now you'll notice these Z items here, 105.2702. Is that actually the elevation out there? No, the elevation out there is like 13 something, right? 1357 something, right? So these are elevations that are based on the benchmark, which was just given right here. That's this shot number 2. It was assigned a temporary benchmark elevation of 100. So sometimes you assign a temporary elevation to something if you don't know the actual elevations. you'll start that at 100, and then what happens is when you can tie that into a benchmark, a known benchmark where you have an actual elevation, this can all be, using a spreadsheet, transformed into the actual elevations. Does that make sense? But in terms of cutting profiles and things like that, cross-sections through the site, you still get the same elevation differences, so it doesn't make a difference. Everyone follow that? So really simple how you would manipulate this data to put it in some type of format like that. Making a comma-separated value system by hand is a miserable process. It's each value separated by a comma, right? Each line also separated by a comma through the entire set of data. That's a lot of data entry. That is a lot of opportunities to make a typographical error, not something you really want to have to transpose too many times. So what we do is we have this handy spreadsheet here, and it converts our radial data out of our data book, our field book, degrees, minutes, seconds of our horizontal angle, horizontal distance, vertical difference, prism height, instrument height, elevation, all of that's right here. We need to make this into a data sheet after we enter our data when we get back to the office so that we can import it into CAD, right? Not everyone has a data collector. Your data collector may die out in the field. Your field book never lets you down. So what I want to do, if I open up another just Excel sheet to show you this, just for show you how simple this is, I'm going to highlight this portion of my spreadsheet, just the data. I'm going to leave the headings in there for now, just so when I rearrange things, I can keep them straight in my own head. But we'll get rid of those after because computers don't like any extra information. It'll corrupt the file. Go to our blank Excel sheet. And when I go in here, there's a function of Excel called Paste Special. So I'm going to right-click, select Paste Special, and I'm going to go to Values. The reason I want values is these cells have some pretty intricate formulas. There's VLOOKUPs in here, there's counts, there's cosine functions, radians, I mean all sorts of math. We don't want that. Why we don't want that is we have a lot more columns here than we need to import into our CAD file, so we have to delete some of these columns. And if we delete those columns and there was formulas, it would be all corrupted. So if I go back to one of those cells, you can see now that it is purely just the value. There's no formulas there. Does that make sense? So if you remember, we want to get this into PNEZD format. So station and backsite, gone, right? Radial angles, prism height, instrument height, don't need, delete. And then description here, PNEZD, D is the last one. So I'm going to cut this, and I'm going to paste cut cells or insert cut cells at the end. So now if you look at my spreadsheet here, I have point, right, P, northing, N, easting, E, elevation, Z, description, D. PNEZD. So the reason that elevation is Z is in your AutoCAD or any type of 3-axis parametric modeling software. When you go into a trimetric view here, you have an x-axis, a y-axis, and the z-axis, where the z-axis is the elevation. That's an excellent question. I should have explained that. So if I go back to my data, I can delete those headings. So now I have something that resembles that text file, right? PNEZD. The only difference is I have here a spreadsheet, and AutoCAD doesn't like spreadsheet files, .xls. It can, however, input comma-separated values, whether it's from a text file, a Word file, anything else. So what I'm going to do is I'm going to file save as, and I'm just going to put this on my desktop surveying. I'm just going to put it in here just for an example, and I'll call it Friday Lab CSV. And under here, instead of saving it as an Excel workbook file type, I'm going to save this as a .csv, a comma delineated value. And when I save that, it tells you that some features might be lost. You lose a little bit of the Excel functionality in it. Macros and some other things can be affected. But we want to keep that format because that's what AutoCAD needs to recognize. Everyone follow me so far? Any questions on that so far? So you kind of get the process behind why we do things in coordinate geometry and why AutoCAD needs to use coordinate geometry and how to get things from radial layout into coordinate geometry. So in a second here I'll show you how to actually work with the AutoCAD file.